Hi everyone, it's Amanda Phillips here with my article share from the NCTM Journal Archive. The article that I read and explored is called Tracking Decimal Misconceptions, Strategic Instructional Choices, and was written by Linda B. Griffin. This was published in April of 2016. I chose this article based on my targeted topic for this course, which is upper elementary grades 4 through 6, work with fractions, decimals, and percent. This is my target area not only because of its dominance within these grade levels, but also the connection it has to students' understanding and the foundations of place value, which really connects to what we talked about last week about the foundations in the early childhood. So this article is really intriguing because it not only addressed the common misconceptions in math, here are some examples and quotes from kids in a 4th grade classroom, but it also shows where they stem from. It stressed the importance of number sense and base 10 foundational understanding in the childhood years. It's important for me as an upper elementary middle school teacher to know where my students have these misconceptions and also why they have them. As Griffin explains in the second half of this first page, these errors and incomplete understandings often present powerful learning opportunities. So it's important for us as teachers to hear and understand those misconceptions, but not just look the other way and not ignore them, figure out where they're stemming from and how we can teach students to correct their thinking. Major components of this article were how we can structure a math class to address these misconceptions, especially focusing around decimals and fractions, and allow students to come to clear and deeper understandings of decimals. 2 days of lessons are outlined in the article, and the featured teacher focused on making connections through asking questions that led to student discovery. There's a whole section here under the launch. For example, students discovered and agreed that words contain deck are related to the number 10. So through making connections and the whole group work, it was really neat to see how lively discussion prompted her students to come to their own conclusions about content. The rest of the math class that's explained in the article was set to whole group work where students created a decimal racetrack, giving them practice with number line, identifying and reading decimals out loud. During this time, the teacher assigned tasks for students to complete in pairs, and she closely monitored, observed, and collected data on student understanding. So it goes into depth and gives really good examples of partner work, different games they can play, and then one of the most powerful tools and takeaways was the power of debriefing at the end of the lesson and reinforcing the learning. During this time, she asked students to point to 1/2 on the racetrack they created during class, knowing that some students would point to 1 2/10, purely because 1 2/10 has the same digits as 1/2. And she talks about how this led to really powerful discussion. And the rest of the article explains other lessons that she could connect to this one, and they all use the same structure, which I really liked. The academic discourse to start, kind of launch it off, whole group work with some real life connection, partner work, and then ending with that debriefing. This article applies to my current teaching position and targeted topics because it not only focuses on the content, like decimals, place values, and misconceptions, but also the structure of a lesson. Connections, whole group practice, partner engagement, games, closing conversations, and it really hones in on the importance of language, asking the right questions, coaching partners through their misconceptions, and supporting students in drawing and creating their own conclusions. I can apply these structures into my math class and use language and lesson ideas right from the article. I really like how the teacher refers back to the activities later on during other topics to help students who are tempted to apply flawed thinking to different decimal problems. By helping our students make connections, we're supporting their understanding of math and their ability to apply strategies to various problems and think flexibly. I'm eager and excited to use these with my own 5th and 6th graders.